I'm Anil Kumar, and in this video we'll try to understand how to incorporate phase shift while we are sketching graph of a sinusoidal function. Probably this is the most difficult aspect of this particular transformation. So to understand that, let me just sketch a sine curve. So I'll just sketch one wave of the sine curve. So let us say this is my one wave, and now we will see how the wave changes or how the position of the wave changes, to be more precise, to incorporate the phase shift in the given equation, right? So let's say that's the x-axis for us, and here we have the y-axis. Sine function, as you know, we are considering 5 critical points. So these 5 points are: at 0 it is 0, then it has a maximum value which will normally be 1, then 0 at half the time period, minus 1 back to 0. That is our sine function, right? So let us consider a general sine function, right? And we say, well, the time period be t for us. In that case, that time period is divided into 4 equal parts to give you these points, right? So the end points are both zeros, and in between we have plus 1, 0 and minus 1. So that is the sine function. This sine function is with phase shift of 0, since it starts from origin and it rises upwards. So here the phase shift is 0. So for the time being, I'll write this function as sine x. So first function which I've drawn here is sine of x. So we are considering amplitude of 1. So these points will be 1 and minus 1 for us. And as far as these x-axis, this is x-axis. So if you're working in degrees, it will be 360 degrees, one cycle 180 degrees, half the cycle 0, and this portion is 90 degrees, and then we have 270 degrees. If you're working in radians, then it will be 2 pi, pi by 2, 1 pi by 2, 2 pi by 2, 3 pi by 2. That is how I count. It becomes easier. So that is your sine wave, which is the default sine wave. Now we will consider transformed sine waves. So what is the effect if I introduce a value for phase shift? So if I write sine of, let us say, x minus 30 degrees. Now what does that mean? It basically means that the sine function starts when x is equals to 30. So if I write x 30 here, I get sine of 0. Sine of 0 is 0. So 30 degrees gives me the starting position. So when you are sketching a graph, how will you get that 30 degrees? 90 degrees into 3 equal parts. So if I divide this into 3 equal parts, let these be 3 equal parts, 30, 60, 90. Do you see that? So this division is now 30 degrees for me, right? So let me write this as 30 degrees. And since I have shifted, or since there is a phase shift of 30 degrees towards the right, each and every point will move 30 degrees to right? So this will get moved to here, this will move to that place, horizontally. Do you see that? 30 degrees. So now the cycle actually starts. So these 5 points for us now are these marked in orange. Do you get the point? Connect these points to get the graph for the transformed function, right? So that is how it has to be connected. So it will start at 30 degrees and will end at 390 degrees. This is what happens when we have a phase shift of 30 degrees to the right, correct? Now let us sketch one with a phase shift towards left. In that case, the equation could be sine of, let us say, x plus 45 degrees. I'm just taking different angles to give you an idea, right? Now, if plus 45 means phase shift is minus 45, so you have to move from the origin 45 degrees to the left. So in your scale, if this is 90 degrees, 45 is that much. So So that means from here we have to move 45 units left. This is minus 45 degrees for us, correct? So each point, the original point, moves 45 degrees left, correct? So these points we are considering this will be here kind of, okay, will move 45 degrees, which is half of this time, right? So that is how you'll get mark those points, move it, and then you can connect, right? So you connect these points. Once you connect these points, then so this point is wrong. This is the point I'm looking for, right? So here it is. So that is the graph for sine of x plus 45. So we move 45 degrees to left to incorporate the phase shift p of minus 45. I hope by now you must have got some idea, right? So let me sketch some more, and this time we'll take angles in radians, right? So let us say we have sine x, and we'll say minus, let me complicate this equation a bit. So we'll write 2x here. Sine 2x minus, let us say, minus 90 degrees. Okay, so that is how I'm writing my wave. Well, I should not take this example at the moment. We'll not take this example at the moment. We'll just keep it sine x minus 90 degrees, because that will change the time period also. So we'll have half the cycle. So I'll not complicate the matter. We'll take those in the next video. So let us have sine x minus 90 degrees. Now what does that mean? Minus 90 degrees means that you're going to move each point towards the right by 90 degrees, correct? So this point will come here, that point will move to this place. So you have a wave which kind of goes like this, correct? I'd like you to sketch this on your own, right? So that one is for you to do. Now let us take up some angles in radians. So we'll take sine of x, let us say minus 60 degrees. Again I wrote degrees. Let me write radians. Pi. 60 degrees is pi by 3. Okay, so it will help both the people who are working, or the students who are working in degrees, as well as in radians. We have pi by 3. You know, pi by 3 is basically 60 degrees, correct? So pi by 3. So when we are working in radians, we'll take one cycle as 2 pi. Minus pi by 3 means it is moving to the right by pi by 3. So we're considering these 5 points, right? And all these 5 points, move them pi by 3 to the right. Now what is pi by 3? So we have pi here, right? 0 to pi divided into 3 equal parts. So it would be like 1, 2, and 3, right? So let us say this much is your pi by 3. So in that case, you move your point so many units. Let's say this is pi by 3 unit, right? So this is pi by 3 for us. So each point is moved that much unit to the right. So here we move it pi by 3. So pi by 3 for us 90. And as you see, okay, so the peak moves kind of here, pi by 3. And this, the green points we're looking into. So this moves to pi by 3. So this much is pi divided into 3. So there it is. So that point moves pi by 3. This point also moves pi by 3. So we have a wave which is kind of like this, right? So do you get it? So if you have a graph, proper graph paper, it'll be kind of simpler. So anyway, what I'm trying to say here is that the wave, the sine wave, when we have a phase shift of pi by 3 to the right, each and every point which we are discussing moves pi by 3 to the right, and you have a wave which starts from pi by 3 and ends at 2 pi plus pi by 3, right? So pi by 3 could be considered, 2 pi could be considered as 6 pi by 3, plus pi will be 7 pi by 3. Do you see that? So that is how you can add pi by 3 plus 2 pi, 6 plus 1, 7. So the wave domain of one wave will be from pi by 3 to 7 pi by 3. I hope with this example you have kind of understood how to sketch graph of sinusoidal function when we have phase shift in transformation, right? So that is what it is. Now, for you, there is a very interesting question. I'd like you to sketch the graph of sine of x plus pi by 2, right? So if you sketch this graph will look like the graph of cos x. Sketch and confirm. Plus pi by 2 means you are moving pi by 2 units left, so that is your minus pi by 2, right? So that is how it is going to be. So whenever you do sine pi by 2 towards the left phase shift, it becomes a cosine graph. So cosine graph starts with the maximum, right? So the points are kind of maximum 0, minimum 0, maximum, right? So that should be a good practice. So these are your practice questions. Try to sketch these graphs and then we'll move forward. Thank you and all the best.